Hello everyone, I am Dr.S.ARUNKUMAR, Assistant Professor, Department of Mechanical Engineering, SNS College of Technology, Coimbatore. So in continuation of the refrigeration and air conditioning lecture series video, here I am going to discuss about the concept refrigeration and air conditioning water systems. So this is the presentation overview. I am going to discuss fundamentals of heat transfer and system components such as chiller, pump and air heating unit and cooling coils and cooling towers. Some of the applications of refrigeration and air conditioning water systems such as commercial heating, ventilation, air conditioning systems, data center cooling and hospital environment. And finally I am going to discuss these design thinking stages followed by one case study, university cooling. So water plays a crucial role in transferring the thermal energy in the many modern heating, ventilation and air conditioning systems. Understanding this system is fundamental for the mechanical engineers. So the water is used as a medium to transfer the heating from one place to the another place. So the fundamentals of heat transfer in water systems. The heat transfer in water systems primarily involves the sensible heating as well as the latent heating systems. The water's high specific heat capacity, it makes it an efficient medium for the energy transfer because the water has the high specific heat capacity. The sensible heat transfer method, a heat transfer that results in the change in temperature without any change of phase of the material. In coming to the lateral heat transfer, the heat transfer that results in change of phase of the materials. For example, the evaporations or the condensations. The evaporation means the liquid stage is converted into the gaseous stage. The condensation stage, the gaseous stage is converted into the liquid stage without any change in the temperature. This is the difference between the sensible heat transfer as well as the latent heat transfers. In the sensible heat transfer, there is no change in the phase. Latent heat transfer, there is change in phase. So the chilled water systems, the cooling core, the water system use water cooled by the chiller to absorb the heat from the spaces and the equipments, providing the effective air conditioning effect. The chilled water is then circulated back to the chiller for the recooling purpose. Some of the components are pump that circulates the chilled waters and air heating unit that exchanges the heat with the room air and cooling coils used to absorb the heat from the air and the chiller is used to cools the water to desired temperature. This cycle takes place repeatedly and it gives the uniform cooling. So cooling towers, the dissipating heat to the atmosphere. The cooling towers are the essential components in water cooled system that rejecting the waste heat to the atmosphere through a evaporative cooling, and this process is critical for the maintaining the system efficiency. So some of the applications in the modern buildings are commercial heating, ventilation and air conditioning system, data center cooling and hospital environment. So the water systems are widely used in the various applications from large commercial complex to the data centers and providing the precise temperature control and the energy efficiency. In the commercial HVAC system, the centralized cooling for the office blocks and commercial blocks and maintaining the optimal temperature for the servers, which is very much essential in the data center cooling. In the hospital environment or medication environment, the critical temperature and humidity control. So coming to the design thinking approach, consider a building manager facing the escalating energy bills and tenant complaints about the thermal discomfort. This is the problem statement. This problem statement is decided by the feedback getting from the customers. So the empathy stage helps define the problems from their perspectives. Some of the problems, high energy consumptions and occupant discomfort and maintenance challenges. So for this problem identification, in the design thinking ideate stage, define stage, we can give a solution for that problem. So in the define stage, we synthesize the insights from the empathy to articulate a clear problem statements. This guides the engineering solution development. So problem statement, how might we design a water-based HVAC system that reduces the energy consumption by 20%, maintaining the optimal indoor thermal comfort. Some of the key matrices are energy usage in kilowatt hour and tenant satisfaction surveys, maintenance frequency. These are the feedbacks received from the customer, and then the problem statement is decided. So one real-time case study, it optimizing the university cooling systems. So before optimization of such criteria, it insufficient chiller, poor insulation and manual control and high water consumption. And after optimization, now the new variable speed chillers integrated with these systems and upgraded insulations, automated controls and reduced water waste, 30% energy saving. As we discussed in the earlier lecture series, integration of artificial intelligence and integration of microcontroller, microprocessor and sensors, and also some hybrid solar powered hybrid systems reduces the energy consumption. So in this case, the 30% of energy saving compared than the conventional air conditioning system after the optimization. So some of the key takeaways are water's role. What is the role in the water in air conditioning system? It is used for efficient heat transfer medium and some of the system components like chillers, pump, cooling towers and design thinking concepts. So these are the some of the references I have gone through for this refrigeration and air conditioning water system concepts. Thank you for your watching. Thank you.